Okay, suppose f is the function of two variable fxy, and its partial derivative with respect to x is defined as del f over del x equal to, suppose we have to compute derivative of the function with respect to x at the point x naught, y naught, then it is defined as f of x0 plus h y0 minus f of x0 y0 upon h limit h is tending to 0. So this is the definition of the partial derivative of the function f with respect to x. Okay, similarly we can define del f over del y at the point x naught, y naught. It is limit h is tending to 0, f of x0 y0 plus h minus f of x0 y0 upon h. Okay, so this is called del f over del x and del f over del y are called the partial derivative of f with respect to x and with respect to y. So del f over del x gives the rate of change of f in the direction of x, and del f over del y gives the partial derivative of f in the direction of, or rate of change of f in the direction of y. Till here we have discussed already in the previous class. Okay, so we have done one question also based on it. Suppose let us start to do some question. Suppose f of xy equal to y sine xy. Then find out del f over del x and del f over del y. Okay, so whenever we are computing del f over del x, then we are treating y as constant. So whenever we are computing del f over del x, then we are treating y as a constant. So keeping y as constant. Then it is coming out to be y as it is, and differentiation of sine with respect to x. So cos xy, and here y is what? Constant. Okay, and you are differentiating with respect to x, then it is coming out to be y. So you are getting here y squared cos xy. This is the value of del f over del x. We are also representing it by f of x. Okay, now compute del f over del y. Del f over del y. So whenever you are computing del f over del y, then treating x as constant. So this is y, differentiation with respect to y. So it is a function of 2y and sine of xy. So y as it is, multiplicative rule, cos xy, then differentiation of xy with respect to y, 2x plus sine xy as it is, and then differentiation of y, it is 1. So it is xy cos xy plus sine xy. So it is simple differentiation. Okay. Now one more example we are doing here, like we are having a function fxy x, that is a function of three variable. Fxy is equal to x sine y plus 3z, and compute fx, fy, and fz. So del f over del x, treating y and z as constant. So it is differentiation of x with respect to differentiation of f with respect to x is 1, and sine y plus 3z is as it is, because here y and z are constant. Okay. Similarly, del of del y can be computed. It is what? X cos of y plus 3z. Differentiation of y is 1. And del f over del z, that means differentiation with respect to z. Sine, cos of y plus 3z, and then differentiation of 3z with respect to z is 3. So this is the value of fx, fy, and fz. Now we compute partial differentiation of the function whenever the function is given in term of implicit form. It's like we're taking an example. There you have to compute del z over del x if the equation yz minus ln z equal to x plus y defines z as a function of two independent variable x and y, and the partial derivative exist. Means what? What you have to do, you have to compute del z over del x. Function is given here, it is given z is the function of two variable x and y. Here x and y are given as independent variable. This is important. Okay, x and y are independent variable, and z is the function of x comma y. It is given z as a function of two independent variable x and y. Okay, so what you have to do, you have to compute del z over del x. In this case, this equation is given in implicit form. What do you mean by implicit form? That means you are not able to express z.
Mixed variable.
Yeah, it is mixed variable, and you are not able to write z in terms of another independent variable. Then equation is called implicit function or implicit equation. So here, now we have to compute the value of del z over del x. So we will differentiate whole equation with respect to x. So differentiate equation 1 with respect to x. Okay. So x and y are independent variable, and whenever you are differentiating with respect to x, then y is constant. Okay. So now y is so y will be a constant. So y is at, so what we will do, we will differentiate as del over del x yz minus 1 of del over del x ln z equal to del over del x plus y. Understand? So differentiation of this, y will be treated as constant, because we are x and y are independent. So y is constant. Okay. So y is as it is. Then the differentiation of z with respect to x, del z over del x minus differentiation of ln z is 1 upon z, and differentiation of z del z over del x equal to differentiation of x, it is 1, and differentiation of y with respect to x is 0. Okay, so the value of del z over del x will be what? It will be y minus 1 upon z equal to 1, and del z over del x will be 1 upon y minus 1 upon z. Okay. So one more example. Let's do. It is okay. So how to differentiate? Like it is same as in one dimension, so it's not a big issue. Next thing is what? In the case of partial derivative, in the case of partial differentiation, it is possible, like whenever we are talking about one dimension, if we are saying a function is differentiable, so you will say the function is, if the function is differentiable, just note, that means it implies continuity. If we are saying fx is differentiable, what does it implies? That fx is continuous. But it is not the case when we are talking about partial differentiation. So a function fxy, so this is the important thing that I'm going to write. A function fxy can have partial derivatives with respect to x and y at a point any point without the function being continuous there. Without being the function being continuous there. Continuous there. That means what? Partial derivative of a function may exist even though function is not continuous. So this case is different than the one dimension. Okay, so partial derivative may exist, but function may not be continuous at that point. So this is different from function of single variable. Single variable. Where existence of derivative implies continuity. Implies continuity. Okay. So let us do one example based on it, where partial derivative exists, but function is not continuous. So this is the case we have discussed here. Now, one example we are going to discuss here. Suppose fxy is a function that is defined like 0 when xy is not equal to 0, 1 when xy equal to 0. So that means what? Xy equal to 0. That means maybe x and y both are 0, or x is 0, y is not 0, and y is 0, x is not 0. So this is the case, xy equal to 0 containing all these three conditions. Okay. And function value is 0 when xy is not equal to 0. Neither x nor y is equivalent to 0. Okay. So then function value is 0, otherwise it is having 1. So what we have to do here, check whether function is continuous or not. Check whether function is continuous or not. Second point is prove that function is not continuous at the origin, at 0, 0. And third point is what? Third part is show that both fx and fy exist at the origin, at 0, 0. Chicken at 0, 0. So let us do it. So if we are talking about this point, continuity, check function is continuous or not. So tell me whether it is continuous or not.
Excuse me, ma'am.
Yes.
Ma'am, can you please?
Pardon? Pardon?
Ma'am, my net just went off. I didn't know what happened in last 15 minutes, I guess.
Okay.
Can you please share the recording after the class?
Yes, sure.
Okay,
Actually,
ma'am.
today there is a problem with the internet in my office. I don't know. I think throughout Thapa today it is happening. I don't know. So maybe. Okay, so wait. Just a minute.
Ma'am, it's continuous.
Pardon?
Ma'am,
It's
It's continuous.
it was all right for me, personally.
Okay, so, okay. Thank you. So we have to check this function is given here 0 and 1, xy is not equal to 0. So we are checking whether function is continuous or not. So it is a continuous function. How you will check it is continuous or not? if limit exists for, if limit of the function exists, what is the definition of continuity? If the limiting value is equal to the function value. If we are talking about a line y equal to x, and we are not including the point 0, 0. अगर 0, 0 का case है तो this is the case. Okay, function definition, we are talking about function definition. When xy is not equal to 0, the function value is what? 0. So we are talking about simply a line y equal to x side. Okay, and x is not equal to 0. Suppose we are talking about y equal to x and x is not equal to 0, then y is also not equal to 0. Then function value is coming out to be what? 0. Okay, so it is everywhere. So function fxy is continuous. Continuous when x comma y is not equal to 0. Okay? 0, 0. So fxy is continuous everywhere. We are not talking about 0, 0 at this time. Now second
मैम ये
point.
रिपीट कर दो.
हाँ, देखिए फंक्शन की डेफिनेशन क्या है? That is 0 when xy is not equal to 0. Suppose we are taking any point, maybe x equal to 2. Then we are taking a line y equal to 2. So the function value is coming out to be 2. Sorry, coming out to be 0. कोई भी point आप लेते हैं, we are not talking about 0, 0. Problem कहाँ पे है? 0 पर. 0 के अलावा if you are taking any of the point, then function value and limiting value, it is same because the function definition, as per definition, it is what? 0. That's why function is continuous. Like we are taking any point when xy is not equal to 0. In that case, function value is what? That is 0. And it is constant. So constant function is always continuous, no? That's why it is continuous. So first point is done. If you have confusion, then ask. After that, second point is what? Prove that function is not continuous at 0, 0. Now we are talking about second case, 0, 0. Understand? Now let us talk about 0, 0 case. If we are taking at 0, 0, f0, 0 is what? The value is what? 1. I told you it means what? xy is equal to 0. When it is possible? When x equal to 0 and y equal to 0. Second case, x equal to 0 and y is not equal to 0. And third point, x is not equal to 0 and y equal to 0. If we are having any of these conditions, then we are getting function value as 1. Okay. So now let us take the, so if we are talking about this one, when x equal to 0 and y equal to 0, function value is what? That is 1. And let us compute limiting value. Limit x comma y, we are taking x comma y is tending to 0, 0. And f of xy. What is the value coming out to be? X comma y is tending to, f of xy is tending to 0, 0. So what we are getting, it is not actually 0, but xy is tending to 0. Then function value is what? 0. Limit x comma y is tending to 0, 0. Is it clear or not? So this value is what? 0. Is it clear or not? Limiting value हमारी क्या है? 0 है. And function value क्या है? 0, 0, it is 1. And since 1 is not function value, f of 0, 0 is not equivalent to limiting value. That's why function is not continuous. ठीक है ना? As per definition. Is it clear or not? Because generally students are getting confused with this example, so that's why I'm asking. It's simple. Function value as per definition is 1 at 0, 0. And if we are computing limit, so limit xy is tending to 0, but it's not 0 now. We are taking using definition of the function. When it is not 0, but limiting value xy, we are taking 0 before that. Function value is what? As per definition, this is 0. That's why we are putting the value of the function, and then we are taking limit, the value is coming out to be 0. Okay, so limiting value is not equal to the function value, so fxy is not continuous.
मैम जो लिमिटिंग वैल्यू है वो डाल के देखते हैं ना वैल्यूज फंक्शन के अंदर.
देखिए, first you will write function value and then you will take limit ना. So function की value क्या है? जब xy 0 तो नहीं है ना, it is approaching to 0. So if you are taking, so as per definition, it is not 0, but it is tending to 0. So before that function value will be what? It will be 0, na? X and y both are not 0, but it is approaching to 0. So whenever it is not 0, then the function value is what? As per definition, it is 0. And then we are taking 0, so it is 0 already. So whatever you take, it will be a 0. Okay?
Yes, ma'am.
Now, third point, so that fx and fy exist at 0, 0. Now, what we have to do, we have to show that.
Excuse me, ma'am.
Yes.
मैम ये रिमूवेबल डिसकंटिन्यूटी हुई जैसे सिंगल पॉइंट में होता था रिमूवेबल डिसकंटिन्यूटी
Removable discontinuity. Removable discontinuity का मतलब एक सिंगल पॉइंट में हमारा होता था sin x upon x होता था. ओके, लिमिट x is tending to 0. ठीक है ना? ये एग्जांपल था. हाँ, तो वो क्या होता था कि आप लिमिटिंग केस लेते थे. Suppose you are taking x plus x, x minus x cube upon factorial thing, and then you are getting x common, and then you are putting limit. Something like that, but not exactly, because you are just first you are putting function value, then देखिए जब भी लिमिट लेते हैं तो हम क्या करते हैं? We will try to simplify our function and then we will take limit. Same thing we are doing here. So here nothing is to simplify. Whatever the function definition, accordingly we are putting value, and then we are taking limit. This is the thing that we do in limit, na? That we have done already.
Yes, ma'am.
Okay. So now third point is what? Third point is what? We have to find out whether the partial derivative fx and y exist at 0, 0. So whenever we have to talk about existence of the partial derivative, whenever we have to show existence of the partial derivative, then we will use definition of the partial derivative. जैसे कि हम generally कोई भी polynomial है या कोई भी trigonometric function है and any other function, those are differentiable, then we can find out directly differentiation. जैसे कि हमने यहाँ पर किया, आपके पास function जो था y sin x y था and you are differentiating it, then it's easy. We have not to use this definition. But whenever you are having limiting case, or it is asked to compute limit of the partial derivative, then we have to use these definition. As in this example, it is asked to check limit of the partial, show that both fx and fy exist at 0, 0. So it is asked to check whether these derivative exist or not, then we are taking limiting case. ठीक है ना? So function is what here, function is given in term of constant. So if we differentiate, it is always coming out to be 0. So in that case, we will not directly use differentiation procedure. We will do what we will do. We'll take use definition here to compute fx and fy. है ना? ऐसे अगर आप करेंगे तो किसी पॉइंट के लिए आपकी वैल्यू तो 0 ही आएगी ना डेरिवेटिव की, चाहे आप 0 को डिफरेंशिएट करें, and either you are differentiating one. So in this case, what we will do, we will use definition whenever function you have this kind of function given to you. So let us find out derivative fx and fy by using definition. So del f over del x, that is limit h is tending to 0, f of x0 plus h. So x0 and y0 is what? That is the point where we have to compute these derivatives. Okay, just a minute. I have to write just a minute. Now, what we have to do, we have to compute del f over del x at the point, suppose x naught, y naught. Then this is the definition. Limit h is tending to 0, f of x naught plus h, y naught minus f of x naught, y naught upon h. Okay. Now, x0, y0 are point 0, 0. है ना? अभी आपको x0, y0 की जगह आपका क्या point है? 0, 0. Now we have to compute derivative by using definition. So limit h is tending to 0, f of 0 plus h, 0 minus f of 0, 0. Okay. Upon 0. So what would be the value of this function from the definition of the function? अभी आपके पास क्या है? Limit h is tending to 0, f of h comma 0 minus f of 0, 0 upon h. तो h0 का मतलब क्या है कि इनका मल्टीप्लिकेशन, अगर हम दोनों का मल्टीप्लिकेशन देंगे तो 0 ही आएगा ना. जैसे कि I told you कि एक भी 0 है तो भी इनका मल्टीप्लिकेशन 0 आएगा, and when it is 0 then the function value is what? 1 as per definition of the function. So f of if we are writing f of h0, then its value according to the definition will be what? It will be 1, है ना? Because h और x और y का multiplication क्या है? 0 आना चाहिए. तो इसका x क्या है? h और y क्या है? 0. So that's why we are getting multiplication at 0. That's why the function value will be what? It will be 1. Okay. So that's why we are writing here limit.
मैम ऐसे तो हर एक केस के अंदर एक का 0 आएगा, मतलब जैसे एक का h, 0 बनेगा हर एक में.
हाँ, तो हमेशा 1 ही वैल्यू आएगी as per definition. So this is 1 and 0 में भी फंक्शन की वैल्यू 1 है. Upon h, this is coming out to be 0. So del f over del x is what? Limit तो exist कर रही है, that is coming out to be 0. Now compute del f del y. Del f del y. Limit, I'm writing directly, f of x0 is 0, 0 plus h minus f of 0, 0 upon h. So limit h is tending to 0, f of 0 comma h. So f of 0 comma h का value जो है वही 1 आ जाएगा. So I'm writing here limit h is tending to 0. This is 1 minus 1 upon h. It is coming out to be 0. So del f over del x is coming out to be 0. Del f over del y, both limit exist and it is coming out to be 0. So in this case, the third part of the question, show that both fx and fy exist at 0, 0. So limit to finite आ रही है ना, तो limit तो exist कर रही है, but function continuous नहीं है. Understand? So this is the best example of the case. Partial derivative may exist in the case of function of more than one variable, but continuity, but we cannot say function will be continuous or not. Okay. So
मैम फंक्शन भी कंटीन्यूअस नहीं है.
function तो 0, 0 पे continuous नहीं है ना. At 0, 0 we checked function value is what? It is 1 and limiting value is coming out to be 0. 0 is not equivalent to 1 ना.
मैम पर आपने स्टेप के अंदर लिखा है प्रूव दैट फंक्शन इज नॉट कंटीन्यूअस एट, मतलब ये तो सही हुआ है, मतलब स्टेप के अकॉर्डिंग ही चले हैं.
हाँ, लाइक आप इससे पहले भी चाहिए. अगर हम वन डायमेंशन की बात करते हैं तो फंक्शन अगर डिफरेंशिएबल है तो कंटिन्यूअस हो गई होगा ना.
यस
फंक्शन है ना. बट इन द केस ऑफ टू डायमेंशन, जस्ट इन द केस ऑफ टू डायमेंशन fxy कैन हैव पार्शियल डेरिवेटिव. तो टू डायमेंशन में ऐसा नहीं होता है कि अगर डिफरेंशिएबल हो तो कंटिन्यूअस हो गई होगा. पार्शियल डेरिवेटिव के बारे में बात कर रहा है. fxy कैन हैव पार्शियल डेरिवेटिव इवन दो फंक्शन इज नॉट कंटिन्यूअस. ठीक है ना. तो यहाँ पे क्या है कि आपने दिखा दिया पार्शियल डेरिवेटिव तो एग्जिस्ट कर रहा है, बट 0, 0 में फंक्शन कंटिन्यूअस नहीं है.
ये
तो
स्पेशल केस है मैम कोई?
पार्डन?
मैम जैसे मतलब इट इज वन ऑफ अ स्पेशल केस.
दिस इज नॉट स्पेशल एक्चुअली. अगर हम वन नॉट स्पेशल केस actually for continuity there required one condition that I am going to state. अगर आपको दिखाना है कि फंक्शन कंटिन्यूअस भी होगा, then उसके लिए आपको दिखाना पड़ेगा जो second derivative. We have to show that with the help of second order derivative that I am going to discuss. Actually it is not the special case. In this case partial derivative may exist, like partial derivative exist, then function may or may not be continuous. So this is the case when the function is not continuous, or even partial derivative exist करते हैं तो हो सकता है function continuous भी हो. Both the case में ऐसा. ऐसा हमेशा नहीं होगा कि अगर function partial derivative exist करें तो continuous नहीं होगा. It may or may not continuous. So this is the case. So this is one of the example where partial derivative exists but function is not continuous. You will get several examples where partial derivative exists and function is also continuous. ठीक है ना. So this is obviously there are very few examples where you will find this kind of situation. Now we are going to discuss what is the surety that the partial derivative exists and function is also continuous. For that I'm going to write a result. What is that result? Before writing result I will just introduce second order derivative and then we will discuss second order derivative. Second order derivative. Fx and fy know what how to compute. Now del 2f over del x square, del 2f over del y square, and del 2f over del x, del y. And I can also compute one more thing, that is del 2f, order can be changed. Del f, del x. Del 2f, del x, del y, and del 2f, del y, del x. Both are same or different? Can you get some idea from here?
Different.
Okay. They are not always equal. They are not always same. Okay. So let us do one example. Fx x comma y x cos y plus y e raised to power x. Now compute all these terms for this function. So fx is what? Cos y plus y. Okay. E raised to power x. Now compute f of y, that is x, differentiation of cos y is minus sin y plus e raised to power x. Now we are computing fxx, second derivative, that is del 2f over del x square. That's important, right, to understand. So del fxx is what? Differentiation with respect to y 0 plus y e raised to power x. And fyy, that means minus x is a constant, sin y is cos y. Okay. Now, if you are computing del 2f, del x is already there, del y, del x. So we are differentiating it again with respect to y. Okay. Del over del y, del f over del x. This del 2f over del y, del x. So whatever we are having in fx, we are differentiating with respect to y. So minus sin y plus e raised to power x. Now we are computing del over del x, del f over del y. Okay. So this is what? Minus sin y plus e raised to x. By chance, this value is what? This is equal to f y x, and this is what? f x y. ठीक है ना? यहाँ f y x की वैल्यू क्या है? By chance they are coming here same, but it is not always the case. Okay, so it is not always the case that when fyx equal to f of xy. So if it is the case, like just note down here, if f of yx equal to f of xy, then if it is the case, then if then fx, fy, fxy, fyx are continuous. ठीक है ना? अगर आपका fxy equal to fyx आता है, in that case all these term will be continuous. तो अभी हमने जो बात की थी पहले कि partial derivative may adjust first order partial derivative, but function may not be continuous. But if second order partial derivative, mixed partial derivative, it is also called mixed partial derivative, mixed partial derivative. Okay, they exist and they are equal. In that case, we will say all function, their first order partial derivative, fx, fy, fxy, and fyx, they are all continuous. Next second order. It is clear or not? So suppose you want to show fx, fy are continuous. So what we will show? We will show fyx equal to fx. बीच में बोलते रहिए. I don't know, sometime I'm feeling like it is disconnected or continuous.
No, ma'am, we can hear you. Please continue.
Thank you. So I think it is clear. So if you want to check whether function is continuous or not, we will try to find out fyx and fxy at some point. And if they are equal, then we'll say function is continuous at that particular point. Like this is one condition. One more note, one more thing that you should understand: continuity of partial derivative implies differentiability. This is important. What does it mean? If the partial derivative fx, fy, and fxy, if function fxy, f of x, f of y are continuous throughout the domain R. Continuous throughout the domain R. Throughout, I should not say only R. R का मतलब सिर्फ यहाँ पर ये नहीं है कि like it is one dimension. It is a big domain. Okay, throughout the domain, then f is differentiable. Then fxy is differentiable at every point of the domain. ठीक है, तो यहाँ पे इतना सिंपल नहीं है जैसे कि आपका वन डायमेंशन में था कि आपने बोला कि डिफरेंशिएबल है तो कंटिन्यूअस होगा ही होगा, या कंटिन्यूअस है तो वी कैन नॉट से इट इज डिफरेंशिएबल. इट मे और मे नॉट बी डिफरेंशिएबल. बट इन द केस ऑफ पार्शियल डेरिवेटिव, व्हेनेवर वी आर सेइंग दिस स्टेटमेंट लाइक फंक्शन इज डिफरेंशिएबल, तो डिफरेंशिएबल है तो इसका मतलब क्या होगा? लाइक डिफरेंशिएबल का मतलब कि फंक्शन fxy and its derivative, partial derivative, they are all continuous, then function is differentiable. जैसे कि हमने पहला एग्जांपल किया था, उसमें क्या था, आपका fx और fy एग्जिस्ट कर रहा था, then we will not say function is differentiable. When we will say function is differentiable, when partial derivative exists and they are continuous, then we will say function is differentiable. Otherwise we will not say it is differentiable. So partial derivative exists doesn't mean that the function is differentiable. If partial derivative exists and they are continuous, then we will say function is differentiable. So these are important notes. Those I'm writing. One more note I'm writing here. Differentiability implies continuity. ठीक है ना? तो अब तो पता ही है कि अगर डिफरेंशिएबल है तो डिफरेंशिएबल होने का मतलब है कि लाइक फंक्शन एंड देयर पार्शियल डेरिवेटिव दे आर कंटीन्यूअस. अब वो कंटीन्यूअस होंगे तो फंक्शन तो कंटीन्यूअस होगा ही होगा ना. तो अगर डिफरेंशिएबल कोई फंक्शन डिफरेंशिएबल है तो हम बोलेंगे दैट फंक्शन इज कंटीन्यूअस आल्सो. सो अप टू हियर एनी कंफ्यूजन यू हैव देन यू कैन आस्क.
मैम फंक्शन इन टू वेरिएबल को डिफरेंशिएट कैसे करेंगे? नॉट पार्शियल डिफरेंशिएशन बट डिफरेंशिएशन नॉर्मल.
दैट इज टोटल डिफरेंशिएशन. एक्चुअली
नहीं मैम, कुछ किसी के रिस्पेक्ट में भी तो करेंगे ना मैम. कोई वेरिएबल के रिस्पेक्ट में तो डिफरेंशिएट करेंगे.
वेरिएबल के रिस्पेक्ट में आप यहाँ पर जो अभी वो फिर टोटल डिफरेंशिएशन होगा. टोटल डिफरेंशिएशन मतलब लाइक वो पोर्शन आपके सिलेबस में नहीं है. पहले हम सिर्फ बात करते हैं फंक्शन के बारे में. बाद में हम बात करते हैं फंक्शन के पार्शियल डेरिवेटिव की. मतलब हम फंक्शन को डिफरेंशिएट कर रहे हैं विद रिस्पेक्ट टू एक्स, विद रिस्पेक्ट टू वाई, है ना? दैट वी आर डूइंग. बट वो फंक्शन जो है वी विल नॉट से दैट फंक्शन इज डिफरेंशिएबल टिल दीज आर ऑल कंटिन्यूअस. ठीक है ना? अगर फंक्शन कंटिन्यूअस भी है, लाइक देयर पार्शियल डेरिवेटिव आर कंटिन्यूअस आल्सो, देन विल से फंक्शन इज डिफरेंशिएबल. अब कहीं ना कहीं ऑब्वियसली दैट यू आर सेइंग करेक्ट, we have to differentiate with respect to any one of the variable. तो आपका फंक्शन जो था पार्शियल डेरिवेटिव तो एग्जिस्ट कर रहा है, बट पार्शियल डेरिवेटिव एग्जिस्ट करने से वी आर नॉट सेइंग फंक्शन इज डिफरेंशिएबल, वी आर सेइंग टेंजेंट लाइक एफ ऑफ एक्स का मतलब क्या है, रेट ऑफ चेंज ऑफ एफ इन द डायरेक्शन ऑफ एक्स, ठीक है ना, वी आर कीपिंग वाई एज कांस्टेंट, दैट इज द मीनिंग, ठीक है। तो विद रिस्पेक्ट टू वन वेरिएबल वी आर फाइंडिंग रेट ऑफ चेंज ऑफ एफ, जबकि वन वेरिएबल में क्या होता है, रेट ऑफ चेंज ऑफ वाई विद रिस्पेक्ट टू वन वेरिएबल ओनली एक्स सपोज, बट हियर we are keeping another variable as fixed, y we are keeping fixed, and then we are finding rate of change of f in the direction of x. तो differentiable तब तक नहीं बोलेंगे, like this term differentiability we will not use till we are not having continuity condition of the partial derivatives.
मैम वो समझ आ गया, बस यही है ना मैम कि मतलब टोटल डिफरेंशिएशन वाला था मैम कि मतलब दोनों के रिस्पेक्ट में कैसे साइमल्टेनियसली हम डिफरेंशिएट करेंगे, आपने कहा वो अभी कोर्स में नहीं है।
हाँ वो पोर्शन आपका है नहीं, वैसे मैं आपको बता देती हूँ, थोड़ा सा एक एग्जांपल लेकर बताती हूँ।
क्योंकि मैम हमने कह दिया कि जब वो डिफरेंशिएबल है तो दोनों के रिस्पेक्ट में ही होगा वो।
दोनों के रिस्पेक्ट में
मैम मतलब टोटल डिफरेंशिएशन तो होगा, मतलब एग्जिस्ट तो करेगा, वो कैसे
total
निकालेंगे?
differentiation like we have to differentiate with respect to x with this, as well as with respect to y, है ना। जैसे कि हमने सपोज एक छोटा सा एग्जांपल देती हूँ, एक मिनट को मैं देखना पड़ेगा एक छोटा सा एग्जांपल, देन आई शुड टेल यू। We cannot write is it visible? Screen is visible?
यस मैम।
So in that case, we can say something like we are differentiating f totally. Like here, we are not differentiating partially. So f is the function of x and y, and x, y are the function of t. Then we are saying this function, like we are computing total derivative as such. है ना? But
ओके मैम।
है ना? But otherwise, like we are using here partial derivatives whenever we are like, फिर से हम उसी चीज पे आते हैं कि पार्शियल डेरिवेटिव यहाँ एग्जिस्ट कर रहे हैं, बट वी आर नॉट सेइंग पार्शियल डेरिवेटिव एग्जिस्ट करने का मतलब क्या हो जाएगा कि वी आर कीपिंग वन वेरिएबल एज कांस्टेंट, देन वी आर कमिंग जब भी हम एक वेरिएबल को कांस्टेंट कर देंगे तो हम सिर्फ वन डायमेंशन में आ जाएंगे ना। देन इन दैट केस व्हाट विल हैपन, f is the function of x and y and we are keeping this fixed. Okay, then जैसे कि आपके पास सपोज x square plus y square है, okay, or just take z equal to, so we are keeping y square as constant, that is y equal to 2. So y square will be what, 4. So what ultimately what is happening, you are getting x square plus 4. So it is what, it is a parabola that in z, suppose x, y and z and x direction, this 4 is fixed. Okay, then we can say something like about it, because now we are talking about a curve. They are the tangent line. So del f over del x, I told you in the previous class also, del f over del x and del f over del y It is giving you what? It is a tangent line that exists on the curve when we are keeping one variable as fixed as y we have taken. So you can understand it in that way. One more
Yes,
thing.
ma'am. I got it, ma'am. Yes, ma'am.
Okay, one more thing, like I just want to tell you, there are lot many videos are available on net. That is the physical description of partial derivative. You should go through it because I tried to explain, but I was trying. Otherwise, in the next class again, I will discuss. I was thinking to discuss today.
Tata
But we
Study
didn't get
trains
time.
your child
So you can
like a
try some
coach.
of the videos.
Its
So
adaptive study planner
the
chalks out a personalized
particular
study
thing will
plan
be
for
more
your
clear,
child.
like we are taking this example. I was just trying. So you can try some examples so that this is a very nice video. You can try this one. If you want, then I can share link with you.
Ma'am, you could share this video.
Yeah,
Yes,
because
ma'am. Please send the link.
yeah, I will send you link because it is very nice because I was trying to explain you in that way, but we are not in front of you, like I'm not in front of you, so I'm not able to visualize you what is happening actually. So I will share this with you. You should try to understand it by this way. If you're not understanding, then you can discuss with me. So let's finish our class here.
Ma'am, which exercise do we have to do? Like the next one?
You should go on LMS. There I आप एक बार LMS को विजिट करो जहाँ पे आपका डैशबोर्ड है वहाँ पे आपको कुछ कुछ प्रॉब्लम्स भी गिवन है जो कि आपको बुक से करनी है एंड ट्यूट शीट इज आल्सो गिवन सो यू शुड ट्राई दैट ठीक है ना तो फर्स्ट चैप्टर यू
Okay,
शुड
ma'am.
ओके ओके थैंक यू
Thank you, ma'am.
Thank you, ma'am.